Hi, my name is Alex Skiba, and I'm
Hello, and I'm Lawrence Patank.
here today to talk to you about C++17, the new C++ standard for, you guessed it, 2017. So at the beginning of this course, we used C++ for the first three homework assignments, and we used many features of the language, including standard library functions like findIf and sort. We created user-defined function and used containers like standard vector, while avoiding C-style pointers and other such things. And the new standard actually includes a lot of features that are relevant to what we did in class, and also plenty that are not. But we'll discuss a little mix of both because we feel that these new features are extremely useful and in the future could be included in this course because of the way that they work and how useful they are to almost every programmer that uses the language. So let's talk about all the new features, or at least a partial subset of the new features that are due for C++17. These include new data types in the standard library for C++, including variant, optional, and any, which are extremely useful for type-safe unions. We have inline variable declaration, like in the C99 standard. We have template argument deduction for constructors, which makes coding new templates and even classes a lot less redundant. We have the if constant expression feature, aka static if, which is useful for doing compile time branching in if statements. We have structured bindings and guaranteed copy elision, which is a more safe way of knowing when things will be copied and destroyed by the compiler when you're creating copies of objects. And of course, there are infinitely many smaller line items on the feature list that we won't tackle here. But for some of you, especially some of you that code in more obscure, edge casey corners of the programming world, that will probably make your life extremely great. But we'll leave that to somebody else to discuss. And our presentation will include a demo of some of these features as we go and later on in the presentation. So first off, let's discuss the new standard data type standard variant. And this data type, which is included in the standard library with C++17, is extremely similar to dynamic language variables being able to contain multiple types. So this allows you to create tuples of variant objects that can hold all these different values mixed in between each other. So this makes things incredibly more versatile, and it also makes union of said variables safe and less hacky and kludgy than you might have had to think up with before. So this standardizes how you would mix those types of objects together and hold them in a single container.
Hello everybody, we're going to go over the standard variant demo for the new C++17. So currently in C++ there's no way to have a variable hold more than one type like dynamic languages do. So in order to combat this, in C++17 they're going to include the variant variable template. So in here you just declare it as variant, and in this bracket area you just list off the types of the variables that you want to include in these variables. So for this case we're going to do int, we're going to do float, and we're going to do standard string because you can also do objects. And then you just set them equal to whatever names you want. Now obviously this isn't going to work because we're still in C++14, but this is the syntax that you would use when the new version comes out. So with this, you can say set w equal to 10, easy, it's an integer in that list. You can also set it equal to hello. And this string is in the list, so that works, but it also overrides this 10, so the 10 is no longer being stored by w. And that's important in the future because it'll, if you say you're trying to pull it, so say int x equals, you can say get int of w. There we go. this will not run because, again, the integer was overloaded, and at runtime it'll try to get it as an integer, which it can be. W can be an integer, but in this case it will not be an integer at this point, so that will give us a runtime error. So you can also, and this is a correct syntax if you want to get the integer aspect of that W. You can also use get, and instead of the type you can say you can have an index. So get2 would get 0, 1, 2, the string type of W. That works. You can set z equal to W. That works as well. So it doesn't really include that much syntax. Most of it's pretty simple. So some compile time errors that you can actually receive is if you were to say get double of z. This is a compile time error because it can infer that the only types that z can be are integer, float, and string, and double is not listed in there. Along with if you're trying to get an index of something that's outside the range. So get 3, there's no index 3 in that list, so getting 3 of z will also give you a compile time error. And if you want to do some debugging, like in dynamic languages, most of it has to be done at runtime. So an easy way would be a bunch of try-catch blocks, right? So you can have the exception. Yeah, the exception there. Syntax for that. And in here, say you want to get the float of z. Oops. Since this is a valid variable type for z, this will not give you a compile time error. However, during runtime, if you're going to run this code, you can see that z gets set to w, which was at this point a string, and so this will again give you a runtime error, and that's why this try-catch stuff would be very helpful to debug those things. So thanks for listening. Sadly, we're not going to be able to do any more demos for you. There's a whole lot of stuff in C++17 that's coming out. This is just one look at something that's really interesting that could be used for a lot of things. And if you guys are interested in representing, you can ask us to do our presentation on one of the other aspects. Thanks again for listening. Have a good one.